almost like ice melts, but instead of turning into a vapor, it turns into other materials. So after 15 days, it's going to turn into 27.5 grams of radium, and the other material just sort of fades away. Another 15 days, and this will again deteriorate into more. So if you wait again with the number of days versus the amount, wait 15 days and it's 27.5 grams. Wait another 15 days, somewhere around 30 here, it'll be 13.75-ish. And so what we're dealing with is this breakdown of this material. We need an equation. Starting at 55 grams, half of it is vanishing every 15 days. That's your ratio we can define, every 15 days. So we could ask how much remains after 60 days. We could plug into our calculator at this point a half to the power of 60 over 15, and out comes a number. So this is where we grab our calculator, and depending on what calculator you have, if you're not using the brick, you'd say 55 times a 1/2 to the power of, and if you're on a TI-83 calculator or an older operating system, you're going to have to use brackets up here, but for this one that has this flashing power position, we get to just say 60 over 15, which is technically a 12, and out comes 3.4 grams. So after 60 days, almost 2 months, we're down to about 3.4 grams. So that's asking, if we know an input, what comes out? As a when will the output be 10 grams, we know the answer is probably going to be a little less than 60 days. We actually have to approach this as a y1, y2, where do they meet? We actually have to wait until chapter 8, logarithms, to be able to solve an output algebraically. So for this question, we'd have to go and type in y1, y2, set a proper window to maybe say, let's call it 50 days might be a nice appropriate time to see. Y value, I know it's 55 grams that we're starting at, and we're decreasing from that, so this should give us a decent sort of expectation. And what we see is the decreasing amount of radioactive material, 10 shoots across, a second trace, intersect, first curve, second curve, bit of a guess. After when it's 10 grams, it will be after 36.89. We'll say after the 37th day, or partway through the 36th day. We'll say on the 37th day, it'll definitely be there. So when the X value was about 37 days, will be less than 10 grams. And lastly, uranium has a uranium-235 is an enriched uranium that has a half-life of 703.8 million years. Just considering that, we're really talking about this isn't a wild time for something to break down. Half of it to vanish takes 700 million years. So when we talk in politics about uranium and plutonium having such a very long half-life, where do we store it? Is nuclear power a good thing? The real strong thing to consider is, where do we store this stuff if we're wanting to be careful about it contaminating things? We talked about these earlier, so I'm going to leave it at that. There is a bit of practice that we should be working on for today, to talk about the base function 2 to the x or 3 to the x, with maybe a little bit of a vertical stretch and a little bit of an application of exponential functions to round things out. But tomorrow, next day,